I'm just waiting for the system to tell me that it is being recorded now. We all should get a message. You are recording now. So welcome, very good morning, everyone. Thank you for coming. It looks like we might have a prompt today. Mark is in Saudi and unable to dial in. I've just received his apologies. Update from us. So obviously 2 weeks ago we saw each other in Cyprus, where we were celebrating our 30th, but also having AGM. Thank you everyone for attending. I have already submitted minutes of AGM to all of you, and I haven't received any comments. So if there is any, please let me know. Subsequently, we had our executive committee meeting, and I have submitted our minutes of that meeting as well, and waiting for comments from you. Thank you very much for prompt delivery of all documents which needed to be delivered to the registrar in Cyprus. This has been submitted now within 2 weeks from AGM, so that's very good. Development since our meeting last time. So I have to congratulate and thank BIMCO for actually listening to Mark, I suppose, when Mark was requesting, asking, appealing to our other organizations to allow ship managers to speak with the voice. And BIMCO has just established the ship management advisory board committee, and Fleet Kishore is requested to be a chairperson of this. And since Fleet is our member of executive committee as well, we've got a very short feedback to BIMCO now and advising on ship management issues. I hope you remember I've sent a message to all of you requesting comments regarding recent BIMCO close, and I have been in communication with BIMCO now. There will be more to come as soon as I've got more information from them. So we are in dialogue here. Another issue, my message during the week regarding new vaccination program in Singapore. And I would really like to hear from members your experience, because it looks really, really good. I have to say, you probably remember that we were always giving a hard time to Singapore for promising but not delivering, not being very clear and making our crew changes really difficult. I think this time the presentation which was submitted to all of you gives a very clear instruction how to do that, and it looks really, really simple and good. So I encourage you, feedback, positive, negative, but please, please, please give us your feedback. What do you think, how things are panning out? Captain Paddy McKnight was in IMO. I'm at MEPC, and I sent a message to executive committee requesting some feedback because of some very interesting development there with ballast water and the positions. So I'm waiting for the response as well. On the vaccination issues, we can see the fourth wave now coming, and many countries, especially in Europe, are really locking down. Austria, it's not a very maritime nation, and we didn't have many crew changes through Vienna recently, but Belgium today announces some changes. So if we've got Antwerp or anything, having said that, they are not making any lockdowns as far as Belgium is concerned. They do accept the fact that they are seeing increased wave of people being affected by COVID, but they are not contemplating any lockdowns. On our social media, I have posted a very interesting, in my opinion, statistics from European Commission regarding relation between vaccinated countries and deaths. If you've got a chance to go there, please, either Facebook or Twitter, have a look. It's a very interesting, and it shows Cyprus actually very well registering on it, not to mention Malta and obviously Portugal. The countries which vaccinated most people are having the least number of people dying. Unfortunately, it doesn't work very well for Bulgaria, for example. And I'm mentioning that because some of us do have seafarers from Bulgaria, Romania. Those countries are not registering very well there. Poland, surprisingly, is not getting too many vaccinated people, but at least deaths are not as high as statistics would indicate we should have. Okay, another update from me. I've done Paddy, MEPC, very good. And what else? I'm just checking here. BIMCO done. I think that's all from me as far as I'm concerned. I would like to open the floor. Is there anything from members? Oh, I've got a feedback, terrible feedback. Could you just mute everybody, please, so we don't hear each other? Unless you want to speak, please. Yes, John, go ahead, please.
I just want to maybe throw in the obvious question here in the wheel about vaccination and death rates. I read it almost every day, CDC, WHO, and the Swedish websites about all this, and it appears that the age profile of the country, the age groups, obesity rate is a key one, and actually smoking is another one, and smoking in the opposite sense. So here, a few weeks ago at the Cyprus General Hospital, the vast majority of the patients in the COVID ward was non-vaccinated, obese, and non-smokers. This is a fact. So just to say vaccination rate and death rate and not look on all the other factors is a bit too simplistic to look on the problem.
Indeed.
So pre-existing conditions and everything else comes in.
Very good. What was mentioned in one of our meetings, industry meeting, was also somebody raised the issue, how come that Africa is not registering that many deaths of COVID? And age profile was highlighted immediately, that Africa has a very low age profile and obesity is not there either. And that is helping them enormously to combat COVID, actually. So you're absolutely spot on, John, definitely. And thank you for that. John, you still have a hand up. Would you like to come back on yourself? No.
I will remove my hand if I can.
Very good. Very good, thank you. Yes, there is another issue which I'm contemplating now, and I went to some members asking how many, because majority of our members are keeping a record, how many members have been, how many seafarers have been vaccinated. And I will be sending message hopefully next week to members if you would like to participate, so we can actually create statistics and see the trends. Are we getting the results as we wish? At the moment, I've got very wide range. Some companies are reporting as low as 25% of the seafarers, and some companies are in the mid-60s. Now, there is another question which is slowing me down with going back to you, is what vaccinations are we talking about? Because really we should only be talking about the vaccination which is recognized around the world. So Sputnik is not recognized around the world at the moment, and having seafarers vaccinated with that, shall we count them in or not? I will get back to you on email and ask you this question because I need your guidance. What would you like? What would be meaningful statistics for you? Anybody wants to say something? John, I think, yeah, John, go for it.
Yeah, because we have Russian seafarers. We have no restrictions on Russian seafarers traveling with Sputnik vaccine anywhere in the world today.
That's very interesting. Okay, thank you for that. Thank you. Khalil?
Yes, on this one, we don't have any restriction, but we had the experience from our crew, some of the Russian nationals, they refused other vaccines. They as individual, they refused when we offered them in some ports, and they said no. So that we have experienced something like this, which was completely opposite.
Yep. Thank you. Okay, and moving on. Yeah, I'm just checking, scanning. Nobody else wants to say anything. Okay, very good then. Thank you for that. Then I would like to open the floor for our guest speaker today. And before we do that, I would like to remind all of us that InterManager is a chair of enclosed space project or committee in Human Element International Group. And as a result of that, we have been doing a lot of work with our members and other associations on this specific subject. And today, Danny unfortunately could not be with us. We've got David stepping in. And I would like to invite David to give us a presentation on, and the title of this presentation, Avoiding Safety Incidents in Confined Spaces. That's because of the product and services they provide. So David, over to you. If you could share a screen, please.
Thank you very much, Kuba. Good morning, everybody. I'm just sharing the screen now. Hopefully you'll be able to see it soon.
Yeah, we see it.
Perfect, thank you. This is to introduce you to something that we call NOMAN, which is for avoiding safety incidents in confined spaces on ships. So I work for a company called EM&I. I've been with them since we started 35 years ago, and I'm the Chief Technical Officer for EM&I. And my main role is looking after all things technical, and in particular technical development, which really these days looks more at things like robotic inspections of confined spaces, not just tanks, but also pressure vessels and that sort of thing. And also looking at artificial intelligence and machine learning, just to speed up reporting and that sort of thing. So looking at confined spaces, there have been many fatalities, I'm sure we're all aware, in confined spaces, and not only fatalities, but also injuries caused by slips, trips, falls, that sort of thing. And all of the stakeholders are very aware that this risk exists. But up until recently, there's not really been much in the way of alternatives available to putting people inside of a confined space to carry out inspection work. Obviously, there's always going to be a need to put people into to tanks and pressure vessels to carry out repairs. But for inspection purposes, there are now alternative methods available. So we're going to look today at the alternative methods, which are both safer and actually practical alternatives, and also cost effective. So the objective today is to discuss if these are viable for the shipping sector, because up until now, most of our focus has been on offshore floating production, although we have done some work onshore and also some work on some drill ships in ballast tanks. So you can see the sort of equipment we're talking about here, and we'll come into this in more detail in a moment, but we're generally talking about optical cameras and laser scanners. So I'm going to look at confined space inspections, the background of NOMAN and why it came into being in the first place, how it works, what class approvals we've got, the benefits. There's a slide on track record, which you can look at your leisure, and then we'll end, if we have time, with a bit of discussion at the end. So looking at the background of NOMAN, there was a joint industry project called HITS, which is the Hull Inspection Techniques and Strategy, JIP, which was formed in 2014. And they came up with various requirements for improving safety and improving the integrity management of floating assets. And one of those was remote tank inspection. So it is made up of the four major class societies: ABS, Bureau Veritas, DNV, and Lloyd's. It also includes some of the major oil and gas operators, such as ExxonMobil, BP, Chevron, Total, Shell, and so on. And also FPSO operators, and in the past, drillship operators, and one or two academic institutions like TU Delft University in Holland. And they got their heads together and decided that one of the things they wanted to look at was to reduce or get rid of putting people inside of confined spaces for the purpose of inspection. And ostensibly that was for tanks, particularly cargo oil tanks on FPSOs. And what they were trying to achieve was general and close visual inspection, structural distortion surveys, thickness measurements, and looking this year at defining cleaning. They've already looked at defects, what tolerance standards there were for various types of defects, what sort of lighting would be required for remote surveys. And we started off using optical cameras. HITS looked at various other things such as UAVs or drones and crawlers, and various studies have been carried out by the HITS JIP, and it was determined that we were not really there yet with these things. Drones are a good stepping stone. If you can put people inside of the tank with the drone and have pilots in the tank, then they're very good and very quick at getting up into the gods and having a look underneath deck heads and that sort of thing. But they have their limitations. Crawlers as well as another problem, particularly in single skin tanker structures where we've got a lot of structure to get around and over. And crawlers are very good on flat surfaces, but not so great when it comes to trying to get over things like longitudinal snifters and around transverse web frames and that sort of thing. So originally the optical part of NOMAN was approved by class, and we've used it for several years, since probably 2016. It's been used on various assets for doing the visual inspections. Class very quickly after they approved the visual said, well, there's certain things you can't do using cameras, one of which, the main one was distortion surveys, looking for an alternative to a surveyor walking around with his torch and trying to find out whether bulkheads and the like were distorted or not, which is very difficult to do when you've got two-dimensional visual information. The next one was thickness measurements, and while HITS has been moving towards trying to get rid of thickness measurements, because after about 30 years of us doing thickness measurements on trading ships and FPSOs and drill ships, turns out that class don't actually do very much with the thickness measurements. There's nothing particularly clever about them. It was just a means of determining whether you'd gone beyond the design limitations of steelwork and due to corrosion and wastage. So we had to find a way of doing both distortion survey and thickness measurements. And to do that, we brought in laser scanning, and we really want to know now whether or not we can transfer the techniques and the equipment that we've got into the shipping industry to look at trading ships rather than just the offshore oil and gas industry. So how does it work? As I say, NOMAN uses two remotely deployed tools, one of which is the optical camera, and you can see in this top image here the optical camera. This particular one is in the bottom of a tank, about 25 meters down from the deck. So it's sitting on a magnetic foot just to stop the camera swaying backwards and forwards. It can be a bit disturbing for anyone watching the video. And we also use what we call synchronous laser scanning. And here we have a laser scanner on a telescopic mast, which has been lowered into the tank. And this is the same laser scanner coming in from the deck in the inverted mode. So we turned it upside down, and that's for looking at the upper areas of the tank. And again, this is just to reduce the amount of movement that we get on the telescopic mast, because the laser scanner has to be steady relative to its environment. And to get rid of any shadow areas, or to at least to reduce them, we introduced something last year called the NOMAN ARM, which is an articulated remote manipulator, which is carbon fiber manipulator. Camera or the laser scanner sits on the end of it, and it has a joint in the middle, so it can be brought up to the horizontal, and that reduces the shadow areas under deck, and also allows us to get from one bay into another. If there's no Butterworth opening available in the adjacent bay, we can swing this around and get into the next bay. So the process starts with planning. We have to look at what sort of access we've got. Top image is just part of a 3D model from an FPSO, looking at the various access points which are available to us. Obviously, on existing assets, we can only use what's there. So we use hatchways and butterworth openings and anything else we can lay our hands on. And we're limited to 160 millimeters for the camera diameter hole, and 300 millimeters for the inverted laser scanner, and 400 millimeters diameter for the scanner in the upright mode, which is sitting on what we call a quad pod. It's just a four-legged pneumatic tripod. So the first thing that happens is that our engineering department look at where the various access points are and what sort of coverage we're going to get from those access points. They put together an inspection plan then and a work pack for the site team, which tells us what areas we can look at, where there are any shadow areas or areas due to sort of structural obstruction or because we don't have the correct access, where we're not going to be able to look. And then that's open to discussion with class and our clients to decide whether those areas where we can't look are critical or not. We also look at the preparation that's required and the cleanliness that's required. Cleanliness tends to be the same as it would be for man entry, only because we're doing visual inspections. And if we can't see what we're looking at, then we can't inspect it. And whether or not we comply with classification rules. Data gathering on site can be done by a two-man team, and you can see here the sort of setup that we've got going through a hatchway. This is actually on a drill ship, and we have a camera on its manipulator going down through the hatchway, and one of our technicians looking at the monitor in front of him, so remotely inspecting. The camera can be put through a nozzle through a pressure headworks, so that the tank doesn't have to be open to the atmosphere. But to do that, you've got to have available the access ports for the camera system. On most recent jobs that we've been doing, we've had class surveyors on board, and that's usually the case these days, but more and more because of COVID and one thing and another, class surveyors are looking towards doing remote survey. And a lot of our development work in the last 12 months or so has been looking at marine satellite communications, which we take with us so that we don't rely on communications offshore, which can be quite poor. Sometimes we can go several days without being able to get emails out, never mind live video. And sometimes we send a naval architect or one of our engineers on board. Depending on how much work's involved, we need to make sure that we're keeping ahead of particularly the laser scanning data that's coming in. Visual data is not such a problem, but the laser scanner data does require manipulation after the event. So data analysis and reporting, all the optical and laser scan data is stored. One of our issues is storage at the moment because we do create very large files, and just trying to get them transported from one place to another remotely is causing us a little bit of grief, particularly with the optical video side of things. So we do produce both flash and final reports. Now, the flash report is done on site, so that you can close up the tank, so that gives you enough information to know what the general condition of the tank, whether there's any reason that you shouldn't be able to close the tank up, and that keeps class at bay basically until we can get the final report out. The optical reports don't take very long to get out. That's probably about a week after we demobilise or done the job, and the laser scanning stuff will take probably about a week per tank, depending on the scope. And here's just an image of putting the laser scanner on its telescopic mast through a butterworth opening. And the sort of coverage that we're looking at, this was a job that we looked at for a new build FPSO, and we were looking for coverage in particular tanks that they wanted to know how much coverage we could get. This is the optical camera with the no-man arm at 5 meters, and the sort of coverage you can get is about half a tank at a time. Looking in this particular case, quite a long tank because it's got a swash bulkhead in the middle of it. And you can see from this image when the camera comes in vertically, we can look into this bay, but using the arm, we can get into adjacent bays if there's no access points in those adjacent bays. Just looking at the results, this is the visual side of things. Class are very interested in doing general visuals of the tank, so looking at larger areas and having a good general look around within the tank, particularly the underdeck areas, which they don't normally get to see unless there are permanent walkways involved. So this is a typical image from the video, so a video still from a moving video where we've done a general look around underneath the deck. And this is the close visual. Because of the cameras that we use, they've got very good zoom on them. They've got pan, tilt, and extreme zoom on. Has its own lighting system as well, and that means that from fairly limited access points, we can get to see a lot of the tank from 1 or 2 positions. Ideally, we would want to have access in every bay to reduce the amount of shadow areas we get. But we can zoom in quite a long way in the dark just using our own lighting system. And our business development people would tell you we can read a business card at 15 meters in the dark. So give you some idea of the sort of zoom that we've got. And one of the things we had to do last year was change our lighting system. This is actually an image of a Lloyd's crack test piece. And this is a 100mm 4-inch crack from here to here, and about 1.5 millimeters maximum thickness. But when we started doing this, all of the lighting was on the camera, and we found out fairly quickly that if you have the lighting and the lens pointing in the same direction, it's very easy to miss cracks because the lighting just basically illuminates the crack and makes it difficult to see. So last year we introduced auxiliary lighting, which is further up the manipulator and gives us angled lighting as well as direct, which means that we can see the cracks very clearly now. The reason for all this sort of moire effect patterning is because this is a photograph of the screen rather than a video still itself. And this is just another typical image of when the manipulator and the camera is down lower in the tank, looking at things like heating coils and piping and support structures for piping and weld toes on deep brackets and that sort of thing. Moving on to laser scanning, here's some images of what we get from the laser scanner, starting over here with the general view. All of these scans were carried out in the dark. The laser scanner can give us some additional information to help with the visual inspections. You can probably see here that we've got some coating breakdowns, top coat peeling off between this longitudinal and this one, which couldn't be seen in the dark. It can be with our camera, but if you're walking around in the dark, very difficult to see. It's quite a long way up the tank and in between the longitudinals, whereas down the bottom of the tank it was fine and at the top of the tank it was fine. But this image gives you an idea of how far the laser scanner will see. This is going 4 bays, probably 20-25 meters from where the laser scanner is sitting on the manipulator through to the swash bulkhead at the other end. The scanners that we use actually have a 150-meter range, but when we're doing thickness measurement, one of the several of the trials we had to do through the HITS JIP was to find out what sort of range we could get to and still have sub-millimeter accuracy on thickness measurements. So if we go to the middle image here, this is a distortion survey of an area of bottom plating. It's about 120 square meters of bottom plating, which has had all the structure removed. These white dashed lines here are where the transverse web frames are. And this is looking at distortion in the bottom plating. And you can see these horizontal stripes are in between the bottom longitudinals. And it's not quite as bad as it seems. Actually, we've probably got about maximum of 10 millimeters of distortion down the way in between the longitudinal stiffness. And the orange stuff at the top here, anything orange is coming towards you, anything blue, purple is going away from you. And this is sludge in the corners of the tank, which is showing up as raised up from the nominal surface. Once we've got our point cloud, we can then zoom in on various areas, whether that be because of things we found optically or stuff that we've looked at when we're analysing the laser scan. This is a bottom longitudinal with an area of corrosion pitting, and we've zoomed in on that area within the point cloud. You can just start seeing the points within the point cloud now. And from one side, we can measure the depth of pits. So we take a nominal surface, a good bit, and measure down in the using the software into the pits and taking various thickness measurements. So wherever you see these little black rectangles, that's got a thickness measurement in it. If we want to measure the thickness of the plate rather than the depth of a pit, we have to scan the object from both sides. So to get the thickness of this bottom longitudinal, we would have to scan from this side and the other. But we can tell from the visuals there's nothing wrong on the other side. So this was the only area there was. So it was adequate enough just to measure down into the pits. This image over here is a composite laser point cloud made up of 4 scans. They are different colours. So you've got the yellow, the light purple, dark purple and green are the different laser scans, and they've all been overlaid to give us a 3-dimensional model, in this case of the cargo oil tank. And again, we can take thickness measurements because we've been above and below stringers. We can take thickness measurements off of the stringer plating. And over here we've got something to keep class happy, where we've identified a plate with the dotted line, and in this case we've taken 6 thickness measurements rather than the normal 5, which are then averaged. But we can average the complete plate and tell you what the average thickness is using millions of points within the point cloud. It doesn't have to be individual points. And just looking at other things that you can do with laser scanning, on the left here, obviously we have the optical image, where the visual inspection has identified an issue with a longitudinal, obviously buckled in the upward direction. So we've gone into our model that we've already collected in the laser scan and gone to look at that particular area. So here is the longitudinal that's bent. And what we're doing here is just looking at what deflection or distortion we've got in the plating beyond that. You just zoom in on that. You can see here that we've got deflections, probably about 35 millimeters in one direction down to 40 millimeters in the other. So between the two, we've got a distortion of 70 millimeters across that plate. Here again, we've got a swash bulkhead where we've got various areas of distortion showing up on the laser scan. And we can measure that. Again, this one is about 25 millimeters distorted from the nominal surface, which is the green. And we can zoom in on the model and pick the worst part of that. And again, in this case, we're looking on this scale down the side here. You can tell how far distorted that is. One of the things that class were interested in was whether or not we could tell whether that was distortion. In this particular case, it's going away from the laser scanner, and by approximately 40 millimeters or so. And to find out whether it's distortion or whether it's wastage, obviously you're not going to get 40 millimeters wastage on an 18 millimeter thick plate. But on some of the plates, it's not quite that straightforward. So we then look on the other side of the plate, and if we have a distortion away from us on one side and towards us on the other side of the plate, then we know that we've actually got distortion rather than any wastage issues. And I think finally, this is the forward bulkhead in the tank. And again, this is looking from a distance at distortion and looking at the various areas of distortion between the vertical stiffeners, which are on the other side of the plate. And we can take thickness measurements anywhere. Once we've got the model put together, we can then go in and take thickness measurements. And that cropped up about 2 weeks ago where we took some thickness measurements and when we were doing the survey. And then class came back to us and said they wanted more thickness measurements. So as if we were going into a tank using rope access or something like that, we'd have had to have remobilised, gone back offshore, taken more thickness measurements. But because we have the point cloud, we can go back in, just sat in an office and take as many more thickness measurements as we need to keep class happy. So the sort of outputs that we get are general visual inspection and looking at the general condition of the tank. Also, any areas of interest such as weld toes and close or local condition. We can provide pitting type reporting, as you saw with that bottom longitudinal distortion, as we saw on the various laser scans, and from the visual inspection, we can report on any other anomalies such as fractures, cracking, that sort of thing. We can also look at coating condition, both optically and using the laser scan, and we are looking at machine learning to try and find out if there's any benefit in trying to get machine learning to analyze coating condition and corrosion areas and that sort of thing. And we can use both the optical and the laser to come up with steel renewal reports. And again, we can use laser scan data after the event to measure areas of steel renewals required. The sort of ship types that we're looking at, mostly they're tanker structures because we're working on floating production ships mostly. Then they tend to be tanker structures, both single hull and double-sided. We've also looked at drill ships on ballast tanks. We could use it on bulk carriers. We've done over the years a lot of inspections on trading bulk carriers, and some of the areas that you'd be looking at are things like the vertical stiffness in hulls. If you want to look at the top of it, it's notoriously difficult for our rope access guys to look at the tops of vertical stiffeners, and corrugated bulkheads is another one which is very difficult. So using this methodology would make it much easier to inspect bulk carrier type hulls. And last year we started looking at gas carriers as well, particularly for floating LNG and FSRUs. And we've just finished doing our first lot of trials through Flow Gas, which is another joint industry project, which looks at inspection or remote inspection, particularly of LNG membrane tanks. And that's going very well. We've got some very good results, both visually and through the laser scanning of LNG membrane tanks. Class approval, Noman Optical has been approved by ABS, DMV and Lloyd's. The laser scanning side of things has been approved by DMV, and we're in the process of approvals with ABS and Lloyd's. We're at the moment going through a series of offshore trials, the latest of which finished last week, and we have another 2 more to do with ABS, Lloyd's and Bureau Veritas. Bureau Veritas are waiting to give us any sort of approval until we've done our final offshore validation exercises with them. So what are the benefits? Obviously safety. We've got no working at height. This is one of our guys doing rope access on a deck transverse. So we get rid of working at height. There's no confined space entry risks. We don't have to scaffold tanks or do any rafting. And there's no long risk exposure times, exposure to things like benzene, offshore things like norms, normally occurring radioactive material, mercury, that sort of stuff. So there are sort of long-term health issues involved in confined space entry, as well as the obvious ones of working at height and the risk of slips, trips and falls while you're moving around within the confined space. We can reduce the people on board to a minimum of a 2-man inspection team. It takes very little time to do an inspection. We could inspect a tank in about 2 hours for a cargo oil tank. Generally speaking, we would quote a day to do a tank in case we come across any anomalies, and 2 days if we're doing the laser scanning as well as the optical side of things. So there's also reduced costs. There's the reduced cost of tank entry preparation. Particularly in the offshore industry, we have to have double isolations of cargo oil tanks. So we have to have physical isolation of all the pipe work going into and out of the tanks, which takes a long time. We still need to clean the tank, as I said earlier, because we can't see what we're looking at because it's covered in process residue or sludge, which is a big problem offshore, not so much on trading ships, because you clean your tanks a lot better than we do offshore. Offshore, we have continuous oil coming into the tank and oil going out of the tank, and they never have to drain the tank. So we can end up with a lot of processed residue in the bottom of the tank. And 2 weeks ago, we were on a vessel looking at a cargo oil tank, and we had about 3.5 meters of sludge in the bottom of the tank. It was up over the bottom longitudinals. So we do need to clean. And obviously, we've got reduced personnel costs because you're not putting 6 rope access guys in a tank. Takes a lot less time, as I said earlier, and it takes the tank out of service for a lot less time than it would if we were doing it by rope access or other means. So we can get the tank back into service very quickly. Don't expect you to read this, but this is just a no-man track record. I'm going to share this presentation with Cuba, and you'll be able to see the sort of work that we've been doing. So there are 1 or 2 oddities in there, onshore work, looking at things like pressure vessel inspections, and even looking at a marine terminal jetty where we were looking at slide bearings, which would have meant having rope access teams climbing over the side of the jetty, but also needing standby vessel underneath the jetty in case for some reason the rope access guy decided he wanted to go in the water. And that's me done, hopefully on time, Cuba. I'm going to hand back to you and see if we have any questions.
Yes, indeed. Thank you, David, for that. If you could stop sharing your screen, then I'll see more people. And if there is any hands up, then I'll let them in. I've got a question for you. I'll pick up something when you said that ship movement, well, the arm has to be steady. How do you deal with that on board of a ship when there is movement of the vessel? So...
yeah, it's not an easy one. With the camera, it's not too much of a problem because people are used to seeing optical images move. And what tends to happen, particularly on ships, as you can imagine, if we put that vertical camera down on the end of a pole, then you'll get so far. We get about probably 5 or 6 meters, and then the pole stays still and the ship moves around it, which gives you a rather like a backwards pendulum effect. But it has the effect when you're watching the video that the camera is swinging. So if we go down further than that, then we can put poles on the bottom of the camera and have a magnetic foot, which one of the images in the slideshow, that sticks the pole to the bottom of the tank and keeps the visual image steady. With laser scanning, it's much more important that it's steady relative to its environment. And you're much more likely to do laser scanning when you're tied up alongside or in a yard or during construction of a vessel, when you're doing baseline surveys and that sort of thing. We are working at the moment on what we call the bridge, which is a truss structure which goes into the tank vertically, is rigged so that we can turn it horizontal, and we can lay the bridge across the 2 bottom transverses. And that gives us a stable bridge that we can put laser scanners and cameras on. The bit we're working on, we've done that in the last couple of weeks, but the bit we're working on is having a pneumatic track, which like a crawler, which drags the laser scanner or the camera to one end of the bay or back to the other, which means that we can also see in the other bays. And we can use the same bridge. You can lift it up and put it underneath the deck transverse, and that gives you a steady platform from which do you laser scanning from the top area of the tank as well. So it's work ongoing really, but certainly it's being improved as we go along. One of the things you can do with a telescopic mast is just reduce the length of the mast. So we can only go probably 5 meters up from the bottom of the tank and 5 meters down from the top of the tank before we start seeing too much movement of the laser scanner.
Understood. Thanks for that, indeed. Okay, anybody else? Any questions? Any comments? David, thank you. There is no further. And as David mentioned, I will receive this presentation probably in PDF and I'll forward it to you. Please bear with me 24 hours for uploading this video because it takes so long to upload everything actually. So David, thank you. Thank you.
Thank you very much indeed, Cuba. Thank you guys. Nice talking to you and hopefully we'll talk to you soon. Bye for now.
Thank you. And now winding down our meeting, I would like to mention also one of my messages which I've sent to you and I had some responses regarding wind farms. Members who are actually operating ships now more than oil and gas platforms, they are moving into the wind farms. And we are seeing some serious issues with the certification as the wind farms are not necessarily prepared for certification. I'm specifically talking about the helicopter transfer. So requirements for people going into the gas and oil are different from the wind farms, and there is hardly any standard for that. So if you are operating any ships which are servicing wind farms, please get in touch. There is a scope of work for ship managers operating those ships, those crews actually operating those ships, and it would pay dividends if we could pool resources and work together. Therefore, please respond to my message. Anybody else? Otherwise, I'll close the meeting earlier today. Is there anything anybody would like to mention? Anything? I'm pausing to see any yellow hands. No. Therefore, thank you, everyone. We'll see each other in 2 weeks' time, and that will be our last meeting of the year. Thank you. All the best. Take care. Cheers.
Thank you. Bye. Bye-bye.
Thank you. Thank you. Bye.
Bye for now.